Hey guys, my name is Branko. The previous episode was all about discontinuing MikroC PRO environment and the features of its successor, NECTO Studio. In this episode, we will walk you through the process of migrating a project from MikroC PRO IDE to NECTO Studio, covering everything from project setup and config to code migration and testing. Let's migrate some examples. I will start light and migrate simple LED blinking project from MikroC PRO for PIC development environment to NECTO Studio. This project has the extension of MCPPI, which denotes MikroC PRO for PIC project. EasyPIC version 8 will be my development board, and I will be using PIC 18 F47K42 microcontroller, just like in the original project. We will migrate this project in steps. We will open MikroC PRO for PIC development environment. We will analyze the project, putting focus on comments section up here, code itself, library dependencies, as well as microcontroller settings. First up is the comments section analysis. The microcontroller we will be using is PIC 18 F47K42 from MikroChip. EasyPIC version 8 from MikroE will be our development board. Clock speed 32 MHz. After analyzing comments, code section is the second analysis to be performed. We can clearly say that this project modifies values inside microcontroller port registers to blink light emitting diodes properly connected to the development board. Third analysis would be library dependencies. No library needed for this simple project, so no library dependencies detected. And the final, fourth analysis would be project settings. Access project settings via the project menu, then edit project action item to analyze microcontroller configuration. What we can conclude is external oscillator with the value of 8 MHz is being used and is being ramped up to 32 MHz using PLL functionality. This initial migration step was all about the project analysis. Now let's go to the second migration step, backing up the project. Ensure project backup for safety, copying the entire folder to a separate disk partition. Locate file path with the help of your preferred file explorer and make sure to copy the entire path with the MCPPI file extension as well. So, run the NECTO Studio right now. Navigate to the Open Project Action button on the left side of the navigation bar in NECTO Studio. Paste the project path in the file name section and hit enter to update the main project window. Choose the MCPPI project to migrate from the main project window and click open. Configuration of hardware/software setup around this project. What does it mean? Well, with Setups Wizard, developers can configure their environments in a few clicks, allowing themselves to focus on what truly matters, the project itself. Now, let's guide you through each step of the setups process. First step would be selecting a compiler. Selecting appropriate compiler is fundamental for the success of any software development project. NECTO's Setup Wizard provides a range of compiler options, each tailored to different project requirements. Whether it is GCC for ARM or RISC-V, Clang for ARM or RISC-V, MikroChip's XC32, XC16 or XC8, MikroC AI for ARM, AVR, DSPIC, PIC or PIC32, embedded software developers can confidently choose the one best suited for their specific needs. How to select a compiler? Click on the New Action button on the upper right corner of the NECTO Studio in order to create a setup. Search and click on the MikroC AI for PIC compiler. Open up Advanced Compiler Options pop-up window. Focus on the Choose SDK version property section of the Advanced Compiler Options pop-up window. Make sure to select MikroC for PIC Legacy 760 as a preferred SDK version. Click Save in the upper right corner of the NECTO Studio. Click Next in the upper right corner of the NECTO Studio. Okay, second step in the Setups Wizard is selecting a development board. The choice of development board lies the foundation for hardware testing and prototyping. NECTO's Setups Wizard offers a comprehensive selection of development boards from MikroE, MikroChip or ST, as well as shields for development boards from well-known hardware platforms including Arduino, Raspberry Pi, STM32 Discovery. How to select a development board? Search and click on the EasyPIC version 8 development board. Click Next in the upper right corner of the NECTO Studio. Third step in this setup wizard is selecting a microcontroller unit. NECTO Setups Wizard presents users with a wide range of MCUs from various vendors, such as NXP, ST, Texas Instruments, MikroChip, and GigaDevice. By offering advanced configuration for each microcontroller unit, embedded software developers can confidently choose the MCU that best aligns with their project goals. How to select a microcontroller? Make sure PIC 18F47K42 with 40 pins stays in the selected mode. There is one note: 64 MHz is the default clock speed in NECTO Studio for this particular microcontroller. By clicking on Advanced Action button, embedded software developers can downgrade the clock speed to 32 MHz as it was previously in MikroC PRO for PIC IDE. Click Next in the upper right corner of the NECTO Studio. Fourth step in this setup wizard is selecting a display, if applicable to the project, of course. For projects requiring visual interfaces or user interactions, selecting an appropriate display is essential. NECTO's setup wizard accommodates projects with display requirements by offering a diverse range of TFT display options, both capacitive and resistive. Users can explore different display sizes to find the perfect fit for their project. Because we are dealing with the migration of an LED project which does not need any display, we will skip this selection of a display by clicking Next in the upper right corner of the NECTO Studio. Fifth step in this setup wizard is selecting a programmer debugger device. The choice of programmer debugger device directly impacts the efficiency and effectiveness of the debugging and programming process. NECTO Studio's setup wizard simplifies this decision by offering a selection of high-quality programmer debugger devices, including CodeGrip, GDB General, and MikroC PRO for various microcontroller families, such as Kinetis, TIVA, AVR, STM32, PIC, DS-PIC, and PIC32. How to select a programming device? Make sure USB-C cable is connected between your personal computer and the EasyPIC version 8 development board. Make sure power button is pressed on the EasyPIC version 8 development board. Then, click Next in the upper right corner of the NECTO Studio. CodeGrip Programmer Debugger Device has been automatically selected as a preferred programming debugging solution. Click Finish to finish the configuration setup. This pivotal stage serves as the culmination of your efforts, bringing together all the choices and settings you have tailored to suit your project's needs. I personally like renaming the newly created configuration setup. Make sure the newly created configuration setup stays in the selected mode. Then click Choose in the upper right corner of the NECTO Studio. Step number 6 would be testing project functionality. Once configuration of the setup of the project had been configured, now it is time for the final test of the project migration. Has it been successful or has it failed? By clicking on the Build Action button on the left sidebar navigation menu of the NECTO Studio, and watching the Issues window in the lower part of the NECTO Studio, and concluding there are no issues with the project, embedded software developers are good to go with the final step of programming the microcontroller. Step number 7, flashing the microcontroller. Utilize the Flash Action button to program the microcontroller using the Configured Programmer Debugger option. If the microcontroller is performing as it was performing while the project was in the MikroC PRO for PIC IDE, you have successfully migrated your project from MikroC PRO for PIC IDE into NECTO Studio. This migration exemplifies a straightforward transition. The project exhibited simplicity, devoid of header files and with only system library dependency. Now, let's delve into a more intricate migration scenario in the example below. So, first step would be project analysis. We will open MikroC PRO for ARM IDE. We will open up the FAT16 project, which is going to be migrated to NECTO Studio. We will analyze the project, putting focus on the comment section up here, code itself, library dependencies, as well as microcontroller settings. First up is the comments section analysis. First comment worth analyzing is the description. File operations will be performed. creating, opening, modifying, and finally deleting of a file. For this action, SPI protocol shall be utilized. UART protocol shall be utilized as well for displaying all the data that is being written to a file. Second comment toward analyzing is the test configuration. We already know microcontroller being used is STM32F107VC from ST MikroElektronika. EasyMX PRO version 7 for STM32 from MikroE is the development board. Clock speed is 72 MHz. After analyzing comments, code section is the second analysis to be performed. Already from the start, there is one header file which is being included. Include library MMC header file. As already mentioned, UART protocol shall be utilized. Library for accessing data on MMC or multimedia card and SD memory card is being used as well. In order to get the file size, conversion and string libraries are needed as well. Third analysis would be library dependencies. This project needs libraries that had just been mentioned. So, conversions, string, type, multimedia card, SPI, and UART. And the final fourth analysis would be project settings. Access project settings via the project menu, then edit project action item to analyze microcontroller configuration. What we can conclude is internal oscillator is being used, 8 MHz to be precise, and we got it ramped up to 72 MHz with the help of the PLL functionality. Project analysis done. Now to the second migration step, backing up the project. Ensure project backup for safety, copying the entire folder to a separate disk partition. Third migration step would be copying the project path. Now, locate file path with the help of your preferred file explorer and make sure to copy the entire path with the MCPAR file extension as well. Migration step number 4 would be opening up NECTO Studio. So, run the NECTO Studio right now. Migration step number 5 would be navigate to the Open Project action button on the left side of the navigation bar in NECTO Studio. Migration step number 6 would be paste the project path in the file name section and hit enter to update the main project window. Migration step number 7 would be selecting the project to be migrated. Choose the MCPAR project to migrate from the main project window and click open. Migration step number 8 would be setup configuration. We already know selecting a compiler is the first thing in the setup wizard. How to select a compiler? Click on the New Action button on the upper right corner of the NECTO Studio in order to create a setup. Search and click on the MikroC PRO for ARM compiler. Open up Advanced Compiler Options. By clicking on the Advanced Action button, focus on the Choose SDK Version property section of the Advanced Compiler Options pop-up window. Make sure to select MikroC for ARM Legacy 6.2.0 as a preferred SDK version. Click Save in the upper right corner of the NECTO Studio. Click Next in the upper right corner of the NECTO Studio, and that's it. Second step in the setups wizard is selecting a development board. How to select a development board? Search and click on the EasyMX PRO version 7 for STM32 development board. Click Next in the upper right corner of the NECTO Studio, and that would be it. Third step in this setups wizard is selecting a microcontroller unit. How to select a microcontroller? Make sure EasyMX PRO version 7 for STM32 MCU card with STM32F107 microcontroller stays in the selected mode. 72 MHz is the default clock speed in the NECTO Studio for this particular microcontroller. Click Next in the upper right corner of the NECTO Studio. Fourth step in this setups wizard is selecting a display. Because we are dealing with the migration of file system project, which does not need any display, we will skip the selection of a display by clicking Next in the upper right corner of the NECTO Studio. Fifth step in this setups wizard is selecting a programmer debugging device. Make sure USB-B cable is connected to the EasyMX PRO version 7 for STM32 development board. Then click Next in the upper right corner of the NECTO Studio. Then make sure to select MikroPRO for STM32 as a preferred programming debugging solution. Then click on the advanced options. Make sure that the executable path for MikroPRO suite for ARM is the correct path. Make sure protocol being used is the correct protocol. Then click on Save button in the upper right corner. Click Finish to finish the configuration setup. And now you have reached the final stage of the setup's configuration wizard in NECTO Studio once again. Rename the newly created configuration setup. Make sure the newly created configuration setup stays in the selected mode. Then click Choose in the upper right corner of the NECTO Studio. Step number 6 would be testing project functionality. Now it is time for the final test of the project migration. Has it been successful or has it failed? So, import was not a success. Importing of this project had been a fail. Nothing to be scared about seriously. Let's fix this issue. Let's focus on the issues window. The second line says CMake error. What we personally like to do in this situation is to go to compile output window and analyze the issue from there. We will just type in CMake error in the search box and we can observe the route to the UART library does not exist. Does it mean this UART library does not exist in NECTO Studio? Absolutely not. UART library for this microcontroller exists and there are UART modules 0, 1 and 2 at your disposal in NECTO Studio as well. Now, because this is a CMake error, we will focus on CMake project file, CMake lists.txt file. We will search for the broken link, sort of speak, or UART 012, and we will remove it from the CMake lists.txt file. That is the first thing that has to be done. The second thing that has to be done is making sure UART library is listed for this project. Because, as you remember, this project expects the UART module is enabled in order to be able to see all the characters being written to a file on the SD card via the NECTO Studio UART terminal tool. So, we will make sure UART library is listed in the CMake list.txt file by searching for it, and yes, there is UART library present. It had been automatically included during the import of the project. Now, perform right click on the project, then select Parse Project Action item, and as a result, parsing a project had been a success. Now, click on the Build Action button on the left side in the navigation bar of the NECTO Studio. Okay, another fail. This is a linker issue. This can happen if we forgot to link a necessary library. Because SPI functionality is giving us troubles at the moment, let's look up whether SPI library is linked or not inside CMake list.txt file. It seems SPI library is linked. Let's look at the library manager feature on the right hand side of the NECTO Studio. If we search for the SPI library, it seems this library is not installed. Our conclusion is that CMake list.txt file is giving us a false positive state. We will provide an instant solution right now, and then we will elaborate in details why this happened. Instant solution would be to just check the SPI library in the library manager. After checking the SPI library and by clicking on the Build Action button on the left side in the navigation bar of the NECTO Studio, the result of building a project was a success. You have successfully migrated your MMC FAT16 project from MikroC PRO for ARM development environment into NECTO Studio. Now, let's see how this issue happened to make it perfectly clear, because there is a possibility some similar scenario could happen to you. So, we want to make it perfectly clear. We will undo the installation of the SPI library by unchecking the box. As we can conclude, there is our false positive SPI library linked over here. It is being called 2 times in this CMake list.txt file, 2 times only. Now, if we go back to the library manager and select the SPI library to be properly installed, we will get one interesting thing over here in the CMake list.txt file. Try searching Ctrl+F SPI keyword. 4 possible matches found. But can you spot the difference between those? Letters, small and capital letters, are the difference. This is the issue. What is the cause? Well, SPI stands for Serial Peripheral Interface. That is an abbreviation. So, grammatically speaking, those 3 letters had to be written with capital letters. So, we changed the name of the SPI library from MikroC.SPI to MikroC.SPI, but with the capital letters. An embedded software developer could ask himself, how this happened? How should I know what are the updated names of legacy MikroC libraries inside NECTO? Here is the answer. If you get these kind of errors, just perform the following tasks. Find the installation location of the NECTO Studio, enter the following path. The last version of the MikroC PRO for ARM IDE is the 620, And this is the reason why we are entering the folder with this exact name. If we go back to the NECTO Studio, SPI3 module had been used for the communication with the SD card. So it seems to us that the folder that we have entered has library SPI123 folder name. But let's perform the double check. Let's get back to the MikroC for ARM IDE. Open up Library Manager on the right side of the IDE and expand SPI library. We are able to conclude SPI library for this particular microcontroller has 3 SPI modules: SPI1, SPI2 and SPI3. So this means we can enter into folder with the following name: libSPI123. After entering the libSPI123 folder, we have been presented with the MikroC SPI MiMake file with the capital letters. We will jump into this MiMake file, which tells me the STM32F107VC MCU, the MCU for this particular MMC FAT16 project, utilizes MikroC SPI with capital letters as a default SPI library module. And why this happened? Why do some libraries have small letters in their name in the MikroC PRO for ARM IDE? If we focus on the MMC FAT16 test MC-par file and we open up this file in any kind of a text editor, VS Code for example, you will be able to witness the fact that SPI library is written with small letters by our software developers 15 years ago. This was the ultimate cause of this whole issue. Step number 7, flashing the microcontroller. Utilize the flash action button to program the microcontroller using the configured programmer debugger option. If the microcontroller is performing as it was performing while the project was in the MikroC PRO for ARM IDE, you have successfully migrated your project from MikroC PRO for ARM IDE to NECTO Studio. This migration example was a bit more complex. We had a combination of embedded libraries and CMake error to be resolved. By following all the previous steps, you can effectively migrate your project from MikroC PRO to NECTO Studio and take advantage of its advanced features and capabilities for embedded software development. Speaking of advanced features of NECTO Studio, if you want to witness and experience some of them, you will be able by the end of the next episode. So stay tuned, and now I will say goodbye.